So this is the 2015 Junior Cert Higher Level Paper 2, and we're looking at question 13. Miriam is trying to find the volume of a water tank shown in the photograph on the right. She takes some measurements and draws a diagram. Part of her diagram is shown below. So here we have her diagram. Part A says, using the diagram, find the value of x. Give your answer in meters, correct to 2 decimal places. Okay, so we have here a right angle triangle, indicated by this 90-degree angle here. We know this angle is 30, the side opposite is x, and the side adjacent is 20 meters. So we should know here that we're going to be using, from the tables book, we're going to be using the formulas for sin, cos, or tan. Okay, so we can see here that the angle A, in our case, will be the 30 degrees. Opposite A, then we have the side marked x. Opposite the A in our diagram, we have the side marked small a. And then we also have the 20 meters, which is adjacent to the angle, which would be B in our diagram. So we're now going to set up the equation using the colors to help us. So we can say that, well, we must look now, are we going to use sin, cos, or tan? So which of these three has A and B, small a and small b in it? That would be tan. So again, just to be clear there, you can see that you've got B, you've got A, and you've got the capital A, the angle. So setting that up, then we have the tan of the blue angle, 30 degrees, is equal to the opposite side, the green one, x, over the yellow, which is the adjacent, 20. So tan of 30 degrees is equal to x over 20. We can rearrange this then. If we're looking for the x, which is the top of the fraction, that x will be equal to the other two multiplied. So 20 multiplied by tan 30 degrees. So we can put that in our calculator. 20 times tan 30 degrees. And that gives us an answer of 11.547, and on it goes. But they want it correct to 2 decimal places. So we're going to look to the third digit after the decimal. Does this 7 affect the 4 in front? The answer is yes. So it's 11.54. Sorry, 11.55. And that's going to be meters, because the other length was in meters as well. So 11.55 meters, correct to 2 decimal places. Part B says the angle of elevation to the bottom of the water tank is 30 degrees, as shown in the diagram. The angle of elevation to the top of the water tank is 38 degrees. Find the distance marked h on the photograph. Give your answer correct to 1 decimal place. Okay, so we said that the angle from here to the top of the tank is 38 degrees. So in other words, that angle is 30, but the full angle there is 38. So the angle in blue is 38 degrees. Now we're asked to find h, which is the height of the tank. So h is this part here. So if we look at the big triangle here, this big triangle, you've got an angle of 38 degrees, you've got an adjacent of 20, and you've got this big opposite length here, x plus h, but we know x, so we're going to be able to use that to find h. So I'm going to set this up on the other page. So the big triangle looks like this. We've our 90-degree angle there. we've 38 degrees here, we've got our 20 here, and then we have the x plus h going up the side, or h plus x, that's this entire length here. So again, using the same idea of color coding here, you can see the angle is 38, that's our angle A. The adjacent is B, 20 in our case, and the opposite side is x plus h, or A in our case. So again, it's going to be tan. As we can see here, you've got the A, you've got the B, and the big angle A. So what we say is that the tan of the angle, 38 degrees, is equal to the opposite, which is x plus h, over the adjacent, 20. So rearranging, we have x plus h is equal to 20 times tan 38 degrees. So that gives us on the right side, that gives us 15.6257, and on it goes. On the left here we have x plus h. Now we've already worked out x from the previous question. We found x to be 11.55, so we can use that. 11.55 for x plus the h will give us this value over here. And that means that h is this value, subtract the 11.55. You can bring this 11.55 over here and make it a negative. So we end up with a height of 4.0757, and up it goes. But we want our answer correct to 1 decimal place. So we're going to look to the second digit after the decimal, and this 7 will knock the 0 up to a 1. So we'll have a height then of 4.1 meters. Correct to 1 decimal place. Okay, finally, part C. Hugh is also trying to find the volume of the water tank. He estimates that the height h is 4.5 meters. By taking measurements from the photograph and performing calculations, use Hugh's value of h to estimate the volume of the water tank as accurately as you can. Give your answer correct to the nearest meter cubed. State clearly what shape you are taking the water tank to be. Okay, so, well, from the picture, you can see that the water tank seems to be cylindrical. So the shape of the water tank would be a cylinder. And then the measurements from the photograph. If you're measuring this photograph from an A4 printout, which is what would have been on the exam, you should get a diameter, in other words the distance across the width of the tank here, a diameter of 5.2. The diameter is 5.2 centimeters, and you should get a height with h, this distance here, of 2.2. So height is 2.2 centimeters. That's what you should get when you measure with a ruler from the photograph. Okay, now, if we remember the estimate, the height was 4.5, so if we write the estimated height over the actual height, 2.2, we can then compare that ratio there to our, I'm going to actually look for the radius now. If the diameter is 5.2, that means means the radius is half that. So the radius would be 2.6. So the reason I'm doing this now is because I'm going to be using or needing the radius in my volume formula for the cylinder, because it's pi r squared h. So the radius then that we're looking for, we can call it capital R over the measured radius, which is 2.6. So we've expressed the estimated height over the actual height as being equal to the estimated ratio over the actual ratio, or estimated radius over the actual radius. So now what I can do there is I can rearrange this to find capital R. In other words, multiply both sides by 2.6. So I get capital R is 2.6 multiplied by the fraction on the left, 4.5 over 2.2. And that gives me a value of 5.318 with the 1 and the 8 recurring. Okay, so there's my radius now. So I'm going to now find, as the question asked, that's the value of h, or sorry, use the value of h, and we're asked to find the volume of the tank. Yeah, Hugh was also trying to find the volume of the water tank. So that's what we're going to do now. Okay, well, the volume of the water tank, remember taking the tank as a cylinder, the volume will be pi r squared h. So for us, that's going to be pi, or for us is 5.318 recurring. That's squared. And then multiplied by the height, which was estimated to be 4.5. So putting all this in the calculator, and we get an answer of 399.842, and on it goes. And that's going to be meters cubed. However, it does say give your answer correct to the nearest meter cubed. So to the nearest meter cubed, then that would be, we look to the digit after the decimal. Does that 8 affect the 9 in front? Yes, it does. And then there's a domino effect, so it's actually 400 meters cubed. So that's the volume of the tank, as per the estimate of 4.5 meters height. 400 meters cubed. And that's the end of the question.